So the machining browser appears over here in the top half of the screen, and the machining objects browser is over in the lower half. And you can always switch between your feature tree and VisualCAM by just single click of a tab. So the part that you currently have designed and loaded is open right here, and we want to go through the process of programming this part using VisualCAM. So the first step in programming this part is to establish the orientation or the direction from which you want to machine this part. By default, you'll see that the coordinate system, your XYZ coordinate system orientation for machining, which you see right here, is in the same orientation as what you have for in your CAD in SOLIDWORKS. So the blue arrow represents your Z-axis, the red arrow represents your X, and then the Y, green arrow represents the Y-axis. So if you take a look at it normal to this view, so your Z-axis is normal to this particular face, what I've highlighted in here, which means you're cutting, that's your cutting direction. But based on the way the part is designed or modeled, it looks like you'd want to basically pocket out these features. So you want to put the Z perpendicular or normal to this face. Am I correct?
Yes.
Okay. So there's a very easy way to orient the coordinate system. So you just go to the Program tab and you go to Machine. And the very first choice under Machine Tool Setup tab is Machine Tool Coordinate System Orientation. So rather than having to go and redefine the part or change your sketch planes and remodel it, you can easily just change the coordinate system in here. You can select a surface, and I can pick this face, and the Z-axis will be oriented normal to that face. Alternatively, you can also use these controls where you have these spin angles in here to rotate your coordinate system. Am I making sense?
Yes.
Okay, perfect. So once you have established your coordinate system for machining, you'll now notice that this has been updated. Your world coordinate system orientation still remains the same, but for the machining, it's now changed. And by default, it is positioned where the origin is in SOLIDWORKS for your part. So if you go into your featured design tree and you look at the origin, that's where it is. And by default, that's where the origin is. But we will go ahead and change those as we go through the process of programming this part. So when you go into Machine, you can go to Machine Tool Definition, and this is where you specify the number of axes. So for 2 and 3 axis, you leave it as 3 axis. We have 4 axis capabilities, starting with expert configurations, which can be like a rotary table where you can index or do a continuous rotation of the part. Index 5 axis, or also known as positional or 3+2 machining, is included starting with our Pro. Premium includes simultaneous as well. So as you're looking at the Pro configuration, you can do 3+2 machining, also known as index 5 axis machining. So you can go 2, 3, 4, and 3+2 machining. So are you working with the 3-axis machine tool?
3-axis currently, and there might be future provisions for a 4th-axis rotary table or indexer.
Okay, perfect. All right. So I'm going to leave it as 3-axis in here. And you can specify a tool change point if you have a manual tool changer. For automatic tool changes, you don't have to. And this can be output in the code, so it makes it easier for the operator to move it to a certain location to make a tool change if you're working with a manual tool changer.
All right.
Okay. So it looks like the units that we are working in here, it shows it's in millimeters. Would you like to work in millimeters, or would you prefer working in inches?
Maybe for this, let's work in inches.
Okay. So we will just
it looks like your tool library is millimeters, so we can save it in that.
Okay. So yeah, we can define a library for tools for English or for millimeters metric units. So here you can see I have a tool library that's in millimeter units, and you can define different tool types: ball mill, flat mill, corner radius, tool for engraving. You got your chamfer mills, taper mills, thread mills, face mill cutters, dovetails, fillet mills for corner rounding, lollipop cutters. So each of these tool types you can define, and you can assign your feet and speeds, your tool numbers. All of this can be set and saved with the tool, and then you can load it in the library.
Let me ask you this: your tool holders in that tool library, can you define like different style tool holders, like Cat 5s or R8 collets or anything like that?
Currently, we only define the holder as a cylinder. We're defining a length and diameter. This is used for the purpose of any holder collisions during simulation. That's helpful if you define the
Okay.
tool, the holder. So you can approximate your holder to a cylinder, and
All right.
allow you to go through it in the simulation. Okay. So the next step is we wanted to select the post processor in here. We have posts for over 300 plus different posts available in the list, so which covers a wide range of machine tools. They either listed based on the machine tool name or based on a controller name. So I understand you're working with a ProtoTrack machine.
Yeah, it's Southwest Industries, but I believe the post processor that they commonly use is just a Fanuc, I believe.
Okay.
Oh, there's a ProtoTrack.
Okay.
There you go.
Yeah, we have a ProtoTrack in here. If it's the AGE3, you just select that right there, and then you can set the extension. I believe they expect .cam as a file extension, so you can just click on New, and then select .cam for their post and output file extension.
All right.
Okay. The next step is we want to build a stock material, so we select stock and box stock. And in this particular process, I'm going to select copy model box, and you'll notice that it automatically computes the extents of the part that you model and tells you that the minimum stock length you need on the X is going to be 190 millimeters, the width is 90 millimeters, and the height of the thickness is going to be 27 millimeters. So you can go ahead and change any of these parameters as you'd like to, or you can just go with a stock that's fits the bounding extents of the part.
Okay. Now, how important is this to have the exact dimensions of the raw stock that I would have for this project?
That would help you when you're doing like a roughing operation. So you want to contain the toolpath to a certain area, establishing your location of the origin and stuff like that. So, stock is primarily used for establishing the material removal for roughing operations and also for simulation purposes.
Okay, and then what is the ignore wireframe geometry and bounds computation?
Yeah. So
box?
If you have some sketches that were modeled in SolidWorks that were outside of the model extents, like some of the sketches that you may have created to either do a cut, revolve, or those sketches that could be extending outside the part. So when you have this unchecked, it'll compute the stock based on all of the sketches that you can see right there. So those sketches probably are visible, but it's taking into account all of those sketch geometries. When you select this and click on copy model box, it'll recompute the stock based on just the solid model that you have in here.
Okay. One other question regarding the stock. There was a part stock option before you clicked box stock option. What's the difference in that? Part stock, part box stock.
So the box stock lets you enter in the length, width, and the height.
Okay.
So basically, by default, it computes the bounding extents, and then you can always input the precise length, width, and the height. Now, in the case of a part box stock, you could specify an offset in each direction in X, Y, and Z. So you could say the stock is going to be 5 millimeters larger in X on each side, maybe 5 in Y, and then the Z you can say you want to just put it in like a positive Z. You can specify just 1 millimeter in a positive Z, or 2 millimeters, or you can do both positive and negative Z. So this basically allows you to just define an offset around the bounding extents of the part.
Okay. Pretty straightforward. All right.
Yep. And you have cylinder stock, part cylinder stock, depending on the type of parts you're trying to cut. You can also do a part offset stock if you happen to be working with like a casting or any of that. And you also have the option to do stock by selection, which is basically a stock that can be defined for, you can bring in a custom model stock and define as a stock from selection as well.
Okay.
So, you can have a pre-cut blank of a certain shape. You can define a stock from selection. So we've defined the stock in here, and you can see that each of these entries that we put in, we selected, we made selections are automatically updated in the machining job in the browser window for you. In the next step, you can pick the material that you'd like to specify for it. So they want to use aluminum, steel, or whatever material type. You can also add additional material types. We have an XML file that you can customize in here. You can just go to this folder, locate this XML file, and then edit it to add additional material types.
Okay.
So selecting a material type will help you in the computation of your feet and speeds, and also can apply a texture when you run a simulation. So if I pick aluminum, you can apply a texture for it for simulation.
Okay.
in the next step, we want to establish the location of your origin, your XYZ origin. So by default, like I mentioned here, it is at the location where the origin is in SOLIDWORKS for the model. But if you want to pick a specific location for origin, you can use work 0, and you can choose where you want to place this. This could be your work coordinate offset or your program 0, and you can choose set to stock, high as Z, if you want to put it to one of the corners, the southwest corner. So it's the setting to the 0 to the top of the stock and the southwest corner. So you asked me a question earlier, how important is defining the stock? So if you're placing the XYZ origin to the extents of the stock, it takes into account the bounding extents of the stock material.
Yep.
You can also apply a work offset number and output your work coordinate offset if it's a G54, 55, or whatever your work coordinate offset is.
Okay.
So the work 0 has now been defined. In the next step, we're now ready to program toolpaths in here. So would you like to basically remove all the material inside this cavity in here, like a pocket?
Yeah.
Okay. So there's different ways you can program it. So for prismatic parts, you could just do like a 2.5 axis operation. Here you also have some fillets in here on the part. We could check the radius. Here, so you have radius of 1 millimeter. So if you want to just do like a 3-axis operation to automatically account for all of these, you can use 3-axis operations to program it. So I could start with the 3-axis and choose horizontal roughing. And in this particular step, I'm going to go ahead and skip the selection of features for machining. So I wanted to look at the entire 3D model that you model in here and look at the stock that's been defined to automatically compute the areas that needs material removal. For the tool, I can pick a tool from the list here. So I have a few cutters like a 1/2 inch end mill, 3/4 inch end mill, 1/4 inch end mill. So I can pick a tool that I would like to go with. Would you have a preference on what tool I use for the demo?
I guess for this roughing, maybe it would be nice to go with a bigger one just to keep the machining time down.
Okay, so we'll go with the 1/2 inch.
Yeah, half inch. Yep. Yeah.
Okay, and then we'll go to feed speeds. You can see that the feeds and speeds are automatically loaded from the tool that we selected. The clearance is set to automatic for all your transfer motions and the non-cutting motions. You can always change the clearance height in here. And then you go down to cutting parameters. This is where you can specify your tolerances for roughing. You can specify your stock to be left after the roughing process is completed. So I could say leave about 1/2 millimeter of stock. And then you can choose the cutting patterns in here. For cavities, you can use a offset spiral, linear, or even a high speed, which is like an adaptive or a bicaudal cut pattern. You can use that right in here. You have each of these controls. You can specify them. And then when you go into core and cavities, so we automatically identify what's a core, what's a cavity in a model. So you can specify different types of step-over controls for core regions, cavity regions. And in the cut levels, you can specify how fine you want the cutter to step in levels. You can use a % tool diameter, distance, or number of levels. I could say the material, you only want to take out maybe 20% of the diameter of the cutter in each pass. So 20% of 1/2 inch cutter. So you're only going down 100,000ths of an inch per pass, right?
Yeah, when you click the adaptive toolpath option, does it automatically change that parameter?
No, you would have to set it. So you'd have to, as an option, you'd have to specify your depth per cut.
Okay.
Yeah. So you can program this using like a 3-axis roughing operation in here, and I can specify, all these cutting conditions that you're looking at right there, and then pick generate. So in this particular process, it's going to look at the part, the stock, and automatically compute the toolpaths. Any questions while the toolpath is being generated?
No.
So there's your roughing toolpath. It does roughing in levels, and you can see that it automatically identifies core and cavity regions. The cutter starts from the outside and works its way in. And we are doing it in multiple levels. As you can see, it's called Z-level roughing. And it's also cutting it around the outside because we did not contain the toolpath to a specific area. Now, if you do want to contain it, so this is one of the ways how you can program it using a 3-axis operation. So it automatically creates your toolpath. So there's your roughing in levels.
And does it have the estimated time for this
Oh, it does, absolutely.
Machining.
Mm-hmm.
It'd be nice to see how the rapid mode, cutting mode, would change the time.
So right-click on information will give you an estimated cutting time based on the parameters, the feeds and speeds that we put in. It takes into account all of your feed rates that you put in, like the plunge, approach, engage, cut, retract, and departure feed rates.
I noticed it didn't cut all the way down to the bottom of that cavity.
Yeah. If you want to go all the way down to the bottom, we can select an option called Clear Flats in here in the roughing operation, and that'll take care of that for us. So I can go down to cut levels and pick Clear Flats, and it'll clean up each of the flats, including the one at the top. So if you want to exclude the one at the top in here, I can pick this face in here and say I wanted to just drop it down by, like, just keep it off the face by maybe take out, a few tops from the top. So it's not going to do the top face on the part. So you have the option to select Clear Flats to clean up the flat faces on it.
Okay, now will that apply to all the flats like that?
All the flats on the these over here, it'll do the flat over here.
Okay.
Yeah, all the flats. If you actually take a look at the toolpath in here, as you step it down, you'll see it goes and cleans up each of the flats down at the floor right there. Flats.
Okay, yeah, I got like five. There's like 5 flat levels on here.
Yep. So it automatically takes care of each of the flats as well.
Could we simulate that? See what it looks like roughed out?
We're going to do that right now. I'm also going to apply different colors during simulation, so it just makes it easier for us to view it.
Oh, okay.
I'm going to go to Simulate and say Apply based on the operation and select Play. So it does each of the levels first and then goes back and cleans up the flats. So now, as you can see, it's cleaning up each of the flats right there.
Okay.
Okay?
Great.
So now the flats are cleaned up. If you want to go back and add another profile pass to finish around these, or you can do a finishing around the part in levels, we have a method called horizontal finishing, also known as Z-level finishing. So I can do a 3-axis and select horizontal finishing. And once you select this horizontal finishing, I could contain it so I don't want to go past the outside boundaries in here. I could use select regions and right-click and choose select loop around the part. So in this case, I don't want to pick this loop here, and I can say select tangency around here. So you see I can pick the entire loop around it by using select tangency. And now I'll pick a tool. Maybe we want to use a tool that has this radius on it, right? So the radius is about 1 millimeter. So we could create a corner radius tool or a corner rounding tool with a 1 millimeter radius. So I can put in a corner radius in here, try to use a smaller tool, maybe a 6 millimeter. I can enter in all the tool properties in here, save this up as a new tool. And now I can go back in here and change all the parameters, the feeds and speeds, cutting conditions. You can specify it to leave no stocks. I can finish it right to the edge of the walls. And you can specify your cut levels, how fine you want the cutter to step. You can also do the same clear flats option in here, and then pick generate to compute the Z-level finishing or horizontal finishing toolpath.
Okay.
So this creates a Z-level finishing. And as you noticed here, we picked a boundary, so it's not cutting past the boundary. If I do not pick a boundary, it's going to do the exterior and the interior. So for the exterior, you may want to do like a profile operation to clean it out. So here, I'm doing a finishing in levels.
Okay.
Any questions so far?
What makes horizontal finishing different than, let's say, profiles or profiling or some of the other 3D?
So the horizontal finishing is also known as, constant Z-level finishing. So the cutter remains a constant Z as you're traversing in X and Y, and it follows the contour of the parts. If you had a draft on it, or so it'll automatically honor that. So it's kind of a profiling, but does it in slices or levels, right? So
Okay.
it maintains a Z constant, so it's ideal for steep sections like finishing these areas. And since you already have a radius in here, it'll take care of that, so you don't have to worry about it. So the toolpath automatically takes care of it for you. Now, for programming some of these areas in here, where you have like these radiuses on the part right here, we can use different techniques. So, for example, I could start with something like a curve machining toolpath, or I can use a curve projection machining, so it can follow those. So I can go to 3-axis.
Okay.
Use a method called curve machining, and I can select a curve, or I can pick an edge here, and I could go start by selecting just these edges in here.
Okay.
So I have those edges selected, and I can specify a tool for it. So I can still go with the same tool, or maybe I can drop it to a smaller tool like a ball mill cutter. And I'm going to say on the curve, generate the toolpath. So the toolpath is actually being projected to the curve. So if I run a verification, you'll see it's just following the curve. The toolpath actually flows along the curve. Now we can add multiple step-over passes in here. I can go back to the parameters. So let's say you want to change the tool to a larger one. I could say I want to go along the curve. I can give it a width, how wide I want it to cut it. So maybe I can measure this point in here, and I can go right up to this point right here. And that's about 7 millimeters in distance. I can give it a distance in here. I could say I want to go about 3 millimeters wide, maybe step it in 1 millimeter or half a millimeter pass. So basically, it'll create multiple passes to follow that. So these are some of the advanced 3-axis capabilities that you have in the Pro, where you can determine what type of toolpaths you would like to accomplish or generate.
Okay, now to try to do this in the 2D programming paths, it would be fairly difficult, correct?
Well, you can't really do a 2D operation unless you flip the part and machine it with the side of the cutter like a profile.
Okay.
Right? You put it on the side.
Yep.
Because over here, you see, if you're doing a 3D cut, you see the tool tip is what you display in the toolpath here. So it automatically compensates for the tool based on the geometry that you're following. And now for cutting the inside over here, you have a like an undercut, right? If you look at it from the side, you probably would be able to use like a keyway cutter to mill the side from the side. But if you just want to do it from one setup, looking down from the top, then we could use a method called curve machining, the same, but then I'm going to just have to draw some sketch in here. So I'm going to use this face and say I want to insert a reference geometry in SOLIDWORKS and create a reference plane. And I will specify a distance in here. So I'll measure this distance. This distance is about, let's see here. I'll say clear the selections. So I want to pick the first reference as this face in here, right? I could do a plane with that face right here and then give it a distance. Insert a reference geometry, a plane, and then I split the difference in here. I'll put it right on the center line. I think it's 1.75. Okay, you see I'm putting it right on the center line right there, sir?
Yep.
And I'll define that. And now I'm going to take advantage of some of the sketch modeling tools in SOLIDWORKS. I'll use a sketch tool, and I'm going to do convert entities. I'll just pick this edge right in here. And it's going to project those sketch onto that plane. Now that I have this curve created in here, I'm going to use the curve machining toolpath, 3-axis curve machining. And I'll go in and select that sketch. So I can just go down from the feature tree, grab the sketch. And over here, I will pick a tool. So I want to use a 3 millimeter. You could use a flat mill or a ball mill, depending on the type of cutter you want to create, right? I'll just go with a flat cutter, and I'll put in basically a tolerance of 0.01 millimeter. And again, the tool path is now being nicely projected down to the floor. So it is checking against the model at each and every step. So if you want to do this in a 3-axis setup without having to rotate the part and use a keyway cutter, this is one of the ways how you can accomplish it.
Okay.
Am I making sense here?
Yep. Yeah, is there any other ways besides going in and creating planes and sketches? Like, is there a way that you can use like a 3D tool path and just select all those surfaces so that it kind of localizes?
We could do what's called a between curve machining in here. So I could do a 3-axis between 2 curve machining. And I can select a set of 2 curves. You can use face edge selections in here.
Okay.
So I have these 2 selected. I'm going to still use the same tool, and I can specify a step over in here. Generate the path. So if you just want to do one centerline pass, that's what I did was created it. So here I could do, between 2 curves. We could also use surface selection. So we have a lot of different techniques how we can pick geometries for machining. So I just showed you if you just want to do a centerline pass, one cut to follow along it. I just had to create a sketch that goes on a center line, so I could drive the toolpath the way I would like it to. So the same thing can be applied over here. Then for the holes, you do a drill and a tap, or drill if it's just a drill. So you have a hole that's 3.454. So you could pick a drill operation in here. And if you do not want to, have an operation that you want to post, or you could suppress it. So right-click and suppress will basically suppress the operation. The operation is still here. It's similar to how you can suppress a feature. You can suppress a machining operation as well.
Oh, okay.
And then I want to do these holes in here. I'm going to go to hole machining and then select drilling. And I could choose select drill points, or meaning you can just select those face edges in here. That's one of the ways to select them. We also have the option to select features on a flat face. We can pick that automatically. So I can select holes of different sizes in here. And you're using the SOLIDWORKS selection menu here. So if you want to drop something, right-click and delete that selection. You just go right there, right-click and delete.
Okay.
Make a choice. You pick a tool for it. And now in the depth parameters, you can specify how deep you want it to go. And you can even use the option to pick here. You can say you want to go from here, and you want to just pick that point right there. That's where you want the tip to be, so you can specify that. So by selecting just 2 point picks, just a top edge, and then you can pick the point right there. And then you don't have to make it a through hole, so you can just clear this checkbox and then generate. You can do standard drill, deep drill, countersunk, brake chip. So we have all the drill cycles built into it. And if the controller for some reason wants to output a linear motion, we can output as a linear motion as well.
Okay. What was the project to 3D?
Yeah, so it'll automatically project if the point that you select is out in space. In some cases, you may want to drill at random holes in different heights. So you can the drill point gets projected down to the 3D model. Depth can be determined by projecting down to the 3D model.
Okay.
So we have drilled those holes. Then if you want to do a tap or any other ream, any other operations, you can always do that by going to hole machining. So once you have all these programmed, right-click and go to information. Will tell you your total cutting time.
Okay.
And you can see that the operation that's been suppressed is flagged in red in the information. So that's not being accounted for your machining time.
Okay.
And then finally, you want to send this out to your machine tool. Right-click and post. Gives you a posted output file.
All right.
See your tool number 1, spindle RPM. Arcs in your toolpath. Calls out for a tool change. The next tool. And finally, at the end of the program, you have an MO2. It says end of program.
All right.
Now, you can also generate a shop documentation, which is a setup information sheet. So if you right-click and pick shop document, you can choose a folder. I'll just put it on the desktop right here. And we have different templates available. I'll pick template 2, hit save. So this is going to actually go and grab a screen capture of each and every operation that you programmed, and it'll display this information in a setup information sheet. It'll also have the information about your stock, the tools that are being used, the feeds and speeds, the total time. So it makes it very useful and handy for the operators in the shop floor to get prepared to see what to expect for each operation that you're running.
Okay. I noticed on these, the pictures within the shop or part setup diagrams, is there a way that you can toggle between different images for that? Let's say like showing the actual stock being removed. So the first one would be like just a box showing the raw stock.
Actually grab the active screen capture. So if I display the stock in here.
Oh, okay.
If I go over to right-click to a shop documentation, and now I'll also zoom in on this a little bit. Makes it easier. So once you have it simulated, I'm going to right-click and choose shop documentation again. I'll just overwrite the same file.
Yep.
So now you'll have a screen capture of what was visible on
your screen. Perfect. That's nice. All right.
Okay. So that's how you can generate a shop documentation. And finally, saving this part within SolidWorks saves all of the CAM information into the same file. So if I do a save as, and I'll just call it revision 1. So all of the machining operations that were programmed is saved with the same document.
All right.
You can always go back and make changes. We also have a very powerful feature called knowledge base. So when you have parts that are similar to these, it requires the same or similar type of workflow. You can take each of these operations that you program and save them all into a knowledge base. You can save individual operations to a knowledge base, or you can save the entire workflow into a knowledge base. So the knowledge base includes your feed speeds, your depth parameters, all the settings that you put in the operation is saved. And when you have a new part that you're programming, all you got to do is load from knowledge base and then load it, and then you just do a regenerate, or if you need to pick regions, you can always double click to edit the operation to go select the machining regions for it.
Okay. How is there any provisions or any ways to handle fixturing, like a vise, ways to mill around a vise or clamps, like milling clamps? Can you actually insert those in there as well?
Yeah, what you asked is a very good question here. So one of the ways we could accomplish this would be by defining a boundary. So right now, that's the way we do it. So we basically pick a sketch as an avoid area, so we can automatically avoid that area from being toolpath.
Okay.
So you can select, let's say, for example, that's the top face. I can create a sketch in here, right? So I can go ahead and throw in a sketch that represents the extents of the part. I'll do a convert entity in here. So let me clear that here. Okay, there's no select loop. Okay, let me do this here. I'm just going to go pick these edges in here to create a sketch. Or let me just throw in a sketch in here. So that might be easier. Okay, so I'm going to go ahead and draw a sketch right here.
Mm-hmm.
So that represents the area I would like to face, for example, right?
Okay.
And I can go ahead and add another sketch in here that represents the areas I would like to avoid. So I can throw in a sketch. I'll pick this face right here. And I'm going to throw in just a rectangle. Oops. So I could say this is the area I don't want it to cut. So my clamps are going to be extending over here. and I'll put in over here. Okay?
Mm-hmm.
So now I could do a 2-axis facing, and I'm going to say select the areas to cut. We'll grab the sketch, which is the area we would like to face, but then I want to avoid it by selecting these. And then I can specify my tool for it, generate. So it'll automatically avoid those areas.
Okay.
So in this 2019 version, this is how we are handling it. We do have an enhancement for our next version. So being able to define specific, like you want to pick a, clamps or fixtures. So that's something we have it in our request for enhancement. So at this point of time, this is the way we can accomplish it.
Okay. Great.
Now you can also program from multiple additional orientations. So if you need to, cut this pocket in here, right? So you don't have to make a copy of this file, save it under a different name. You can just insert a new setup, and you can say you want to flip the coordinate system over by 180 degrees. So now that basically lets you rotate the machining coordinates. So you can go back and refix the part on the machine tool. You can establish your work 0.
Okay, now this work 0, I can set that to part now, right? Because when you flip it over in the mill.
Absolutely.
Okay.
So you can flip it over, you already have it machined out, or you can even pick a center of a hole. You want to pick a point, wherever you want to put it to, right?
Okay.
You can do that. And you can pick a corner, set to part. And now I want to do this pocket in here. I could use 2-axis pocket machining. Since it's a prismatic, there's no drafts in there. I can right-click and say select loop. So pick the entire loop around the part. Grab a tool for it. I could just use my 3/4 mil. Specify the cut pattern. Cut levels. You can specify if you want to leave any side stock. You can do that. And in the cut levels, you could say determine the depth using 3D model, or you can even say just pick the top face and the floor. That's a 0.5 millimeter. Generate. So that gives you your high-speed cut pattern. You can also insert a cleanup pass in the same operation. Add a cleanup pass. Generate it.
Okay.
So you had the simulated the drill operation in here. Now we want to go ahead and run the pocket. So if you want to delete an operation, right-click and cut will delete it.
Okay.
You can simulate it from multiple orientations as you see it. And now finally, you want to go back and put the fillet in here. So I can check what the radius is. It's a 2 millimeter. So if you have a special cutter that can handle that, like a round over bit, you can put in the corner radius for that, 2 millimeter. I'll save this up as a new tool. I'll add a operation, profiling. I'm going to select and right-click on this and use select tangency in here. Grab that entire loop around the part. For the tool, I'll grab this fillet mill cutter, beats and speeds, clearance. I'm just going to leave the default settings, cut on the outside, and cut levels. You can set entry and exit, generate. So that'll go ahead and take.
So it automatically finds out your levels for that. Okay.
Yeah. So you can see in one pass, I was able to machine the fillet with a tool that matches the radius of the fillet.
Okay.
Corner round tool.
Nice.
Yeah. So the Pro gives you the ability to program from multiple setups. And if you want to do multiples of these parts, you can also do what's called an instancing of the toolpaths, XY instance. And you can specify the spacing in X and Y. You could say the spacing in X is probably 200 millimeters. Y is maybe 100 millimeters. You could say one extra copy in X, one in Y. And I can take this profile and place it in here. So this basically does multiples of the same.
Oh, okay.
Yeah, I can repeat it. You can always go back and change the spacing if you want to adjust it. Like, say, for example.
Is there a way to do that for all of the milling operations? So let's say if
you can do it for all
if you wanted to. Okay. Okay.
Yeah, you can place one or more operations. You can group them based on the tool priority or the operation sequence priority into it.
Okay.
So also the Pro gives you the options to do advanced 3D machining operations. So for example here, we did the roughing toolpath. Once you're through with the roughing operation, you could go back and do a 3-axis re-roughing, so which looks at the stock from the previous step, and you want to go back and rough in areas where a larger cutter could not get in. So the re-roughing comes included. You have advanced finishing methods.
Okay.
Like we look at screen curve machining, pencil tracing. All of the advanced 3D methods are in the Pro.
So re-roughing is the same as like a rest machining operation?
Rest roughing operation, that is correct.
Okay. I noticed in the 2D toolpaths there was remachine or something like that instead of re-rough. Okay.
That's a remachining in 2D. We have it in 3-axis as well. So if you take a look at this operation in here, I could go back and add a 3-axis horizontal re-roughing. And I'll grab a smaller tool. For example, let's go with the 3, from a 1/2 inch down to an 1/8 inch. You can specify your cutting conditions in here.
Okay.
You can specify the stock to leave. I can drop it down to maybe just like, 0.2 millimeters.
Yeah.
Yep. And your step down, you can put in all the parameters. You can also tighten up the tolerance for fitting arcs to it. So we can output true arcs as well. And now when I generate this path, this will automatically identify the areas that were being left from the previous operation.
Okay.
We can also.
I noticed you put that. Yeah, you put that in before the curve machining operations. Is that just a matter of? Can you reorder these operations within that history tree?
Absolutely. You can just do a simple drag and drop. So you can select it here.
Oh, okay.
And you can say you want to place it after the curve machining.
Perfect.
So I can put it right here.
Okay.
And now it will regenerate. So if it's not able to find any areas, you won't be seeing much of a toolpath. I can notice that after we did the curve machining, the re-roughing only cut a small section here.
Yep. Oh, nice.
You can do drag and drop, very similar to how you can drag and drop files, to rearrange it.